Imagine, if you will, standing on the shore of a vast, dark ocean. You have a message, a story about who you are, where you come from, what your world is like. You place it in a bottle, seal it tight, and cast it into the waves, knowing it may never be found. But the hope, the sheer audacity of the act, is what matters. In 1977, humanity did just that. We didn't use a bottle, and our ocean wasn't water. It was the vast, star-dusted emptiness of space. Our bottle was a spacecraft named Voyager 1. Its primary mission was a grand tour of the outer planets, a once-in-a-lifetime planetary alignment that would allow a single probe to visit Jupiter. On September 5, 1977, a Titan IIIe rocket roared to life at Cape Canaveral, Florida. It was a pillar of fire and smoke, a controlled explosion powerful enough to defy Earth's gravity. Perched atop this behemoth was Voyager 1, our little robotic explorer, waiting to begin the journey of a lifetime. Interestingly, its twin, Voyager 2, had actually launched 16 days earlier, but Voyager 1 was placed on a faster, more direct trajectory. Its path was a carefully calculated arc designed to get it to Jupiter first, a cosmic shortcut that would set the stage for its entire mission. The launch was flawless, a perfect start to a mission that would redefine our understanding of the solar system. The bottle was now in the cosmic ocean, and its long, lonely voyage had begun. For the next year and a half, Voyager 1 sailed through the blackness of space. It crossed the orbit of Mars and navigated the asteroid belt. Voyager proved it was more like a vast, empty desert with occasional rocky oases. It was a quiet time for the spacecraft, a long cruise phase where its systems were checked and its trajectory fine-tuned by commands sent from Earth. These commands, traveling at the speed of light, took minutes to arrive. In early 1979, Voyager 1 arrived at Jupiter, and humanity's view of the gas giant changed forever. The blurry, indistinct images from Earth-based telescopes were replaced by a spectacle of breathtaking detail and violent beauty. We saw that Jupiter was not a placid ball of gas but a world of raging storms, swirling clouds, vibrant colors. The famous Great Red Spot was confirmed to be a colossal anti-cyclonic storm, a hurricane so vast that 3 Earths could fit inside it. Voyager's cameras revealed a complex, dynamic atmosphere, jet streams, eddies far more powerful and intricate than anything on Earth. It was a weather system on a planetary scale, a masterpiece of fluid dynamics painted across a canvas 100,000 miles wide. But the wonders didn't stop with the planet itself. Voyager 1 turned its gaze to Jupiter's moons. Io, for instance, was a geological bombshell. Instead of a dead, cratered rock, Voyager discovered it was the most volcanically active body in the entire solar system. We saw, for the first time, active plumes erupting from its surface, spewing sulfurous material hundreds of miles into space. This was a consequence of the immense gravitational tug-of-war between Jupiter and its other large moons, constantly squeezing and heating Io's interior. While Voyager 1's primary mission was planetary science, it actually carried something else. Something intended not for us, but for whoever or whatever might find it, millions of years from now. Attached to the side of the spacecraft is a 12-inch, gold-plated copper disc known as the Golden Record. This is our message in a bottle. It's a time capsule containing sounds and images selected to portray the diversity of life and culture on Earth. The project was chaired by the great astronomer Carl Sagan, who understood that this was our chance to send a greeting across the cosmos. It contains greetings in 55 languages, sounds of nature, wind, sounds of nature, whale song. A curated selection of music, Bach, Beethoven, and Chuck Berry, Johnny B. Good. The contents of the Golden Record are a poignant summary of our world, 116 images encoded in analog form. Images include the structure of DNA, a mother nursing her child, diagrams of our solar system, photos of our cities, photos of the countryside. The sounds tell a story too. There's the cry of a baby, the sound of a train. After its flyby of Saturn, Voyager 1's planetary mission was over. Its new mission, an extended one, was to become the first human-made object to reach interstellar space, the space between the stars. For decades it traveled outward through the heliosphere. This giant magnetic bubble is blown by the solar wind, a constant stream of charged particles from our sun. The bubble envelops our entire solar system and shields us from harsh galactic radiation. Scientists knew the sun's influence would eventually wane and the true interstellar medium would begin. The edge is called the heliopause, and finding it was Voyager's next great quest. For years, Voyager sent back environmental data. Scientists watched as solar wind speed slowed, a sign they neared the boundary. The spacecraft passed through the turbulent heliopause sheath, where the solar wind bunches up against the interstellar medium. Like the bow wave of a ship pushing through water, the data trickled back, taking longer and longer. By the 2010s, one-way signal time exceeded 16 hours. Communicating became an exercise in extreme patience. Then, in 2012, something extraordinary happened. Voyager's instruments detected a sudden, dramatic change. Charged particles from the sun plummeted. High-energy cosmic rays from the galaxy shot up. It was like stepping from a quiet house into a raging storm. After months of analysis, NASA concluded, on August 25, 2012, Voyager 1 crossed the heliopause. It had popped through the bubble. For the first time, a human-made object entered interstellar space. A monumental quiet boundary crossing echoing historic voyages. This transition is not just symbolic, it's a scientific goldmine. Voyager 1 is now our only direct source on this unexplored territory. It's sampling, for the first time, the interstellar medium. Gas dust cosmic rays that fill the void between star systems. It's measuring the strength and direction of the galactic magnetic field, untainted by the sun. It's telling us what the universe is really like out there. Every piece of data is revolutionary, the first of its kind. It has transformed our understanding of the solar system's place in the galaxy, revealing how our stellar home interacts with its cosmic neighborhood. This is the legacy Voyager continues to deliver. As of today, September 1, 2025, Voyager 1 continues its journey through the interstellar void. It is now more than 15 billion miles away from Earth, a distance so vast it's almost impossible to comprehend. A signal from the spacecraft traveling at the speed of light now takes more than 22 hours to reach us. That means a simple hello and we hear you exchange with the probe takes nearly 2 full days. It is the most distant and loneliest human-made object in existence. Its instruments, though aging, are still functioning, still measuring the properties of its environment, and dutifully reporting back what it finds. Its faint signal, just a whisper of power, is captured by the massive radio dishes of the Deep Space Network here on Earth. The spacecraft is living on borrowed time. Its plutonium power source is slowly decaying. The energy it can generate diminishes with each passing year. To conserve power, engineers at NASA have been systematically shutting down non-essential systems, one by one. First the heaters for some instruments, then entire instrument packages.